Is this working now? Can you hear me now? Okay, cool. Yeah, good. So yeah, I just had it before with the depth of field turned off, so every particle is drawing as a single pixel-sized circle. And then here's with depth of field turned back on. So yeah, I think it makes it a bit harder to tell what's going on, so I'm probably going to do most of my dev today with depth of field off, just so I can see what's happening, but it definitely looks cooler. I'm really happy with how it like qualitatively looks like gravity, like it settles into a plane and like gets these little clusters. Yeah, there's motion blur when I zoom in and out. Basically I just take the current and previous screen position of the particles and then blur between those. Like I do a smeared line along that. Yeah, it's pretty fun, especially with a little bit of depth of field. It's pretty fun to like just like whoosh. Okay, that's actually, you need either a lot or a little, I guess. Here we go. Yeah. There we go. It's fun. I don't remember if I had dithering. I think I did. Yeah, I have dithering on right now. Okay. Yeah, it looks like jumping into hyperspace or something. Okay, so what I'm trying to do on this stream is right now I can draw a lot more particles per frame than I can simulate. I'm printing out timestamps for. No, this is actually a pretty high-end GPU. This is a 2070 Super. So yeah, I could probably scale down the number of particles, and it would still run real time on like a lower-end GPU, but yeah, it'd have to be a lot fewer particles, I think. But yeah, no, don't be under the illusion that this is not a beefy GPU. But anyway, so what I'm trying to do is basically it's taking me on the order of like 0.1 milliseconds to actually draw all the particles, which means I could draw like 160 times the amount of particles that are there, but it's taking me a full like 4 or 5 milliseconds to simulate, which means I could only simulate like maybe 2 or 3 times more. Let me just, I have like a number of particles. Let me just try increasing this to twice what it is, and I think it'll still run smoothly. But if I go much higher than that, then it will. What happened to my particles? Oh, I think I might have forgotten to update this in some places. Like maybe the shader. Yeah, the shader also just has it hard-coded in. Okay. Let me see if there's anywhere else. Yeah. Okay. I thought I changed the stream title. I guess I didn't hit update. Yeah, no, last time I streamed, I was working on. Let me find it. I don't remember where it is, but yeah, if you look on my last stream on my YouTube channel, I was working on a Game of Life thing with like, it was a 2-color Game of Life for like a strategy game. Yeah. And what I'm gonna do is not full Octree. I'm just planning to try to do a grid for now because it's much easier to make a flat data structure like a grid on the GPU than a full-on tree. And the tree would be like asymptotically more efficient, but it'd be hard to accomplish in the first place. Okay, yeah, so here's my 8,000 particles, and it kind of just blurs into a mess with the depth of field, so I'm going to turn depth of field back off. Where did I set? Oh yeah, it's in the draw shader. Everything in here is just like hard-coded at the position. Quad tree would be in 2 dimensions, and octree would be in 3 dimensions. So this one would be an octree since it's 3D. But I'm just gonna do a 3D grid for now. So yeah, here we go with 8192 particles, and the it's only taking me still about the same time to draw. Like it's like 0.2 milliseconds ish. But it's up to, yeah, so it scales non-linearly because I'm doing an n-squared naive algorithm. I'm just, for every particle, I'm looping over every single other particle. So when I increase from 4,000 to 8,000 particles, my time goes up from 4 milliseconds to 16 milliseconds, which is, there's like hitches, like you can see it's not fully smooth. Like it's hitting about 30 frames, but it's also hitching every once in a while. Anyway, so my goal is, I don't know how good it will look. I might honestly want to turn off motion blur as well, because at 0 depth of field and this kind of motion blur, or maybe I should just like clamp the motion blur paths, but they just all look like lines and it doesn't look good close up. But anyway, I want to get like an order of magnitude. Wow, that's cool how far I can zoom out. That's really cool. There's just so many particles here. Anyway, yeah, I want to just see how far I can push the number up. So what I'm gonna need to do is right now I just have 2 buffers that I'm double buffering for previous and current positions. And I'm using the Verlet integration algorithm for integrating the gravity equations. So what I'm gonna need is another, at least one more buffer for building the grid, and then another compute shader step in my pipeline for actually building the grid. And I've been thinking about this, and there's a wide range of approaches I could take to building the grid, ranging from simple and probably not very efficient to like really complicated but much more ideal. So like probably any like reasonably good solution requires some kind of sorting. Hey Lewis, thanks for tuning in. Solid bodies as masses of particles. Yeah, nobody does that, because I mean here's an algorithm. I mean, here's an argument for why that's just like a bad idea. Because unless you want soft body, then imagine like the matrix of all the like forces, like couplings between all the particles. All of the particles making up a rigid body, like all the forces are constantly canceling each other out. Like it's just all you actually, like the entire point of why rigid body physics is easy is that you can project down that massively high dimensional space of all the particle positions into like 6 dimensions for XYZ and like your rotation configuration. If you're doing soft body, then you could, but like you would probably get much better results doing some explicit kind of discretization approximation where you have like I don't know if particles being involved would make any sense at all. Like you'd have some kind of mesh. Like for fluids, you often have particles involved in some way in the simulation. Like you have particle and cell method where you compute the motion of like subsets of the fluid as particles, but then you discretize field properties in the ambient space in a grid that the particles move in. But yeah, I don't think you do anything like that usually for soft body, but I know nothing about soft body simulation, so. Anyway, so let me remember how to set up a second compute shader here. And then I also need to set up a new buffer. Let me first think about what kind of buffer I want. So like, the challenging part of this is that each cell can have sand and snow. That makes sense. Time to ban someone from the chat. Okay. Goodbye. Anyway, yeah, that makes sense. Sand and snow, like, qualitatively seem more particle-like to me than, like, I guess silly putty is like a kind of a fluid. I don't know. Sounds really hard. Yeah, the vultures are descending on my stream chat. Okay, so the hard thing about this is that I have a fixed number of particles globally, and I can have a fixed number of grid cells globally, but the number of particles per cell varies, and I can't control that. So I need to somehow divvy up the space in my buffer for the particles. And since I'm doing it, since it's on the GPU with like massively parallel like shared memory concurrency, I need to have some kind of lock-free algorithm for building the buffer. So here is one that I don't know if it would perform well at all. Basically building a linked list of particles for each cell. It'd be pretty high overhead because there's a memory round trip for every next particle you read, and it like doubles the storage. But I know it would work because you can atomically push each particle onto the linked list. I could possibly do something like linked lists of blocks. Or I could have a two-stage thing where I have each cell count the number of particles and then I do a scan to compute the buffer sizes. Or I could just do the worst case allocation and have like grid cells times total number of particles. And that's probably what I'll start with. It will waste a lot of memory, but it will avoid a lot of complexity, I think. So I'm going to do that. PVD without grids, constraints on the edges of a mesh. That makes sense. Yeah, I really know nothing about how soft body stuff is done in practice. Okay, so yeah, I'm going to start with just doing a pessimistic worst case sized buffer with the number of total particles times the number of grid cells. And then I can just sidestep the problem and just make each grid be a fixed size thing. So I'm gonna say the grid is going to be, let me think, if it's 32 on a side, then I have 32,000 grid cells, which is like 268 megabytes to store, or like it's about a gigabyte to store all of the particles with that like pessimistic approach. So it might work. I think I have enough VRAM for that. Not the best. I could also just allocate less than that. Anyway, let me just say 16 for now because it will probably fit, and then I can do more sophisticated stuff later. So let me make a buffer for my grid. And then what am I going to store in the grid? So I think I'll just store particle indices in the grid. And I only need, let's just use 32-bit indices. So, because the whole point here is getting as many particles as I can going. So let's just have a flat list of 32-bit indices of particles. And then when the sim is looping over grid cells, it will just have to look up each one of those. It's not the best. Like I said, sorting would be a more efficient approach because I can put nearby particle data together in the buffer, but sorting's harder. So okay, so if I have a grid full of indices, I also need to have like the grid header information, which will just have the total number of particles in the grid cell. Or I could just have I can just avoid that for now. And have a sentinel at the end of the list. But I do need another. So with the Barnes-Head algorithm, after I've binned all my particles into a grid, I need to compute like a summary approximation for each cell in the grid. So like the central optimization is that when you're updating a particle, you treat every other particle that's not in its same cell as hasn't you treat the entire cell as a point mass. So like in this case, that means I just sum up the mass of the particles and then take the average position of the particles and then treat that as a point mass. So I need somewhere to store that. So I need, let's say grid buffer is the one holding the indices, and then I don't know what to call it. Let's just call it grid approx buffer. So this one is going to be full of I32s, which are the indices of the particles. It will be particles.length times times it's the grid size cubed. So pretty big, but I'll figure that out later. So grid size cubed times number of particles. I mean, if it were adaptive, I could guarantee that it was like half the particles on each side of a division, if it were like a KD tree. think I can just give it a null and hit null. Maybe. Okay, yeah, it will be uninitialized if I do null, which is okay because I'm going to write to it before I ever read from it. So, yeah, here we go. Got the grid buffer, and then let's link the grid approx buffer, which will, instead of having particles.length, it'll just have and since it will have both positions and mass in them, it will need to have 8 times num particles, so I'm storing 8 floats, which is 3 floats for position, 3 floats for previous position, and then 2 more spots for alignment. So, oh yeah, so I don't need to do particles.len, I need to do num particles, that's important. And then for my approximation buffer, my size is going to be grid size cubed times it will have 4 floats for XYZ and then mass. Let me look up shader storage buffer alignment to double check that I won't be like if I still need to align to 8. I think I can probably align to 4. Let me just see what happens. I'll keep in mind that it might be failing for that reason, and then I'll do it just align to 4. So it's 4 times size of F32. Oh no, that's not the grid buffer. This should be I32. No, that's I32. This is F32 and it should be 4 times, but I need to... Okay, let's make sure I didn't mess anything up. Not using these buffers yet, but... Okay, and let me turn it back down to... 4,000 just for now. So I have my buffers, and then I need to make a shader for first binning all the particles. So let's make bin.jlsl. I have draw, update. Oh, quad is how I'm rendering the final thing. So I need 2 more. I need bin, and then I need approx. So here are my 4 shaders. So bin and approx are the 2 stages of the Barnes algorithm, where bin sorts the particles into their respective tiles, and then approx computes the average position and total mass of a tile. So let me just copy paste this to have somewhere to go from. So I do need to read from the particles, and then I do need to write to the grid. So the grid is going to be it will have 4096 times the grid size cubed, and then I have my global invocation ID. So I think I'm going to try running one thread for each tile for now. So I need to, and I can probably just do when I invoke it, I'm just going to use X, Y, and Z. Because compute shaders get like dispatched on a grid of up to 3 dimensions. And previously I've just been using a one-dimensional invocation. Okay. So let me just clear all this out for now and see if I'm compiling properly. I think that it will complain about a prox. No workgroup specified on line 96, which is from a prox. So yeah, that makes sense. Then a prox is going to take in both the particles and the grid. Oh, it's the grid in. Okay, so it's building. Now let me actually invoke these. So I have my buffers, I have my shaders, and then I'm gonna do the same thing as this. Let me start leaving some comments in here. Someday I will clean this up to be in any way like reusable. I'm just trying to get it working for now. Okay, so I'm using the bin shader, and I'm binding the current particle buffer. So yeah, I'm using particle buffer 1 as the previous frame and 2 as the current frame. And I swap the two every frame. So yeah, I should be passing the bin program, particle buffer 1, and the name of it is particles in, and the name of the second buffer is grid out. But instead of particle buffer 2, it's grid buffer. And then instead of dispatching num particles, like I said above, I'm dispatching we pass it U32. Okay, so grid size is U32 for X, Y, and Z. So let me see if this runs. And it should be doing nothing, but yeah, it runs, so we're good. And then I'm gonna hook up the Prox shader, which should look similar, but it takes the grid buffer as input, and it produces the grid approx buffer. Oh, it also has to take the particles. Zero, 1, 0, 1, 2, and it's the same number of invocations as the binning program. I have particles in, grid in, and then I also need to make a grid approx out. So I'm going to have a 4 vector for each particle, with x, y, z being the position and w being the mass. Hey, Tiny Pillow. Okay, so I'm now invoking my approx shader. Particles in, grid out. Particles in, grid out. This should be set up right. Let's see if it runs. Okay, line 95 is the approx shader. Oh, it's grid particles out. Yeah, okay. There we go. Yeah, okay, so we're still running. So let me actually start writing it now, because I think everything should be in place. So for the grid, I have invocation ID X, Y, and Z are my tile coordinates. So I'm going to start by saying this is the number of particles I've found so far in my grid cell. Let me extract this out into a constant. I'm not going to bother to actually pass it in from the Rust side yet, but I may as well avoid changing 10 locations every time. Does GLSL have const keyword? Seems like it. Const int let me just do that in here as well. and then should be here as well. Okay. Actually, let me make sure that change works before I start writing more. Pretty good. Okay, so number of particles we found so far is 0. And then for every particle in the list, we are going to get its position. And then ideally I would be sizing the grid to like the current extent of the particles, but I'm just going to choose an arbitrary grid size. What is my range that I start with? Okay, so, and good news, that shader still runs fine. So it spreads out a lot. Honestly, what I might do is just like stop taking into account particles as they go outside of my grid, and then choose a grid that just encompasses this area, and it will be slightly broken, but it will work for now, and it'll be easier to get working. So I spawn my particles in a range of, it's a radius of 400, it looks like. And they expand, but not drastically except for like the outer ones that escape. So if I do like a size of 1,000, 1,000 on each side of the grid, that should be good. So let me say my so it's going to be a cube of 1,000 to a side centered at the origin. So that means that my cell position is going to be it'll be my invocation ID, X, Y, and Z. I think I can just swizzle it real quick. So cell size is going to be grid dim divided by grid size. So this is an integer vector that's ranging from 0 to 15. So if I convert it to a float vector and then multiply that by cell size, that should give me my, make it a 3 torus. Yeah, I could. Yeah, there's like a fundamental question of what is the distance you take for the gravity force fall off, and like you could say it's just the shortest geodesic, but I think I mean really, if you want to do it right, you have to think about if it's an inverse squared law, you have to think about it propagating in multiple directions in the space, and if it's general relativity, then it's just like hard differential geometry to solve. So yeah, it's not just shortest. Yeah, you could probably do some kind of like like list of paths, and there's like an infinite series of paths, and you could stop at some point. Long story short, it doesn't make my problem any easier to solve. So I'm just going to neglect particles that are outside of my grid and figure that out later. So here's my cell min, and then I'm going to say and then I check if the particle is inside cell min and cell max. So I think you can just compare entire vectors. And then what I need is, I need to add the index of the particle to my list. My list is stored in grid particles out, and my so I'm going to store this with it seems like you could do it, the toroidal thing, because like each path would be getting longer. So actually, there's probably a pretty sensible cutoff point where you could decide it doesn't matter. But yeah, it's like an interesting problem in and of itself. Like if I wanted to explore that, I would probably not be doing it in a compute shader and do it like in WebGL or Love2D or something. Anyway, so my list offset is, I'm gonna arrange it so that it's the x coordinate is like, there's a grid size squared sized slice in the array. So the x is choosing which of those you're in. Y is choosing which row in that slice you're in. So it's, and as long as you do this consistently, then it will give me the same offset. So list offset grid particles out indexed by list offset plus num particles equals I, and that tells me that particle I is in the current cell. Oh yeah, that makes total sense, because a crystal is basically like, it's basically like you describe the world as a 3 torus, right? Like you assume that the crystal is infinitely repeating. That makes total sense, yeah. Reminds me of the NerdSnipe XKCD, where the original problem was the infinite grid of resistors, which like you can probably solve in the same way. Like it's just like a perturbation expansion thing, which I've just been nerd-sniped. But anyway, so it doesn't like that I cast a uint to an int on line 28. Oh, that's on line 23. Line 23, maybe I should make grid size be a uint, but I might fail elsewhere. That didn't change it. Yeah, so it's saying I cannot compare entire vectors, so that's sad. You can take min and max of them, but... Okay, so if... So just have to compare each dimension individually. Do I have a hang in my shader? Oh no, it just took a long time to compile for some reason, I guess. It's weird. Maybe because I saved the file at the same time, so it locked on the file or something. Worst experience of my life was one time I somehow had a thing happen where my shader file got over into a blank one because the program had it open for compiling it with OpenGL, and I tried to save it at the same time. I don't know how it happened. I didn't have it in version control, so just like goodbye to my shader. Anyway. So I am building the grid. I'm probably going to try using RenderDoc to see if the grid is being built now, because that will be easier than actually trying to show it in some way. Compute, target, release, compute.exe, just launch. And then capture. Okay. So compute pass number 1, my first input. Particles in. It's not a texture. That's confusing. Oh, it's just looking at. Let's grid out. Pipeline state, compute shader. Grid out has no resource. So yeah, apparently I'm not even allocating and binding the resource properly. Slot 2 is grid out. Binding equals 1. Grid out. Grid buffer. Oh yeah. Bin. And then when I'm dispatching it, that's confusing to me. In any case, I know this part's not going to work. Okay, so what is not... Let me look at my resource inspector. It just says there's no resource at all. I know I'm creating it. It's a shader storage buffer. Grid buffer. Where am I creating that? Maybe because I'm passing nulls. Let me just make some 0 arrays too. So let me see if that works. Actually 0 the memory instead of giving a null. Okay. I shouldn't have closed Random I should have just relaunched. Okay. Compute pass. Pipeline state. That looks pretty cool. Compute shader. Still no resource for grid out. I don't know why it's on slot 2 instead of slot 1. So binding equals 1. Okay, where am I binding it? So bin particles in, grid out. Well, so it wasn't the problem that I was not passing it 0, so that was just giving me a null. Can I see the data? How many bytes is that? Okay, 67 megabytes. So that's not too bad for now. View contents. It's getting some stuff written to it. Oh no, that's a different buffer. Yeah, I can't see what could be going wrong here. But yeah, it's just not binding anything. For the grid buffer. Okay, let me see if I'm actually successfully writing to it. Okay, let me look at buffer 46 again. I guess it's called buffer 47. Hey, it worked now. Worked this time. So maybe something about this line is messing it up? That's so weird. Like if I take out the line where I actually write to the buffer, then it works. Man, it loves to just take forever to allocate the humongous buffer, I guess, is probably what's happening. I didn't even capture. Okay, compute pass number 1, dispatch compute, pipeline state. Okay, so I did fix that it's not getting bound. And if I view the content, okay, I think it's working now. Can't look at further, I guess I can. So it is getting written to, which seems to me like it's successful. Oh yeah, so how big would this buffer actually be? So it's 16 million entries, so this is not the whole thing. But a single cell entry is going to be how do I view this as pipeline state, grid out. That's not enough bytes. I don't know what's going wrong here. Yeah, I'm allocating with, this should be like 16 million or like 64 million bytes. And it's like 65,000. So that's confusing. Hello, welcome to the stream. Currently trying to figure out why my buffer is mysteriously getting allocated as smaller than I asked for. Still says 65536 bytes. This does make sense as a result of what the algorithm is doing. So like I think the logic is correct. Oh yeah. Of course. Well, I have another one that's bigger though, so that's the like the other one bound in that same shader is just like 4 times as big. Pipeline state, compute shader, grid out. It still says, this looks like it's spaced more correctly though. Okay, so let me check back when I allocate the buffer. So yeah, it should be 4 million bytes. Let me check if there's no GL error after I do buffer data, so that's confusing. Oops. And I'm doing the same thing as I do down here. Let me just do something smaller and see what happens. It still says 656. Maybe I should just ignore that and just go on and see if it will work. Yeah, okay, I'm just going to leave it. Okay, so this should be binning the particles. So then let's move on to the approximation shader, where I do a similar thing. Let me just copy paste these constants in. And then I want to For my own bin, I want to loop over the particles. Let me do what I said before, where if I get to the end of the list, I write a value that's in 32 max or something. So that marks the end of my list. Yeah, because the index can't ever be larger than the number of particles. Yeah, so I'll just do number of particles on that. That index can never be a valid index, so it's a good sentinel for the end of the list. So let me get the same list offset, and then I loop over the particles, but instead of getting a position, I get offset plus I. And then so this, I don't put a sentinel at the end of the list if somehow all of the particles got in this one cell, which is very rare, but I don't want to overwrite the next cell. Okay, so I can get rid of this. I get the index, and then I can grab the position of the particle, so if I see the sentinel, that means I'm at the end of the list and I want to break. And otherwise, I get the actual position from that index. I'm going to start out with 0, and then I accumulate, because right now what I'm trying to do is I'm going to compute the average position of the particles in the cell. So I'm going to add them all up in position, and then at the end I will divide position by the number of particles. And I want to write these out to my grid particles out buffer. So this is my output, and I'm going to stick it in grid particles out. So, and my index is going to be just this. So I should be calculating my total mass and average position in each cell. And that really takes forever to start up. Okay. Read-only variable. This needs to be write-only. I guess it's just taking forever to compile for some reason. Or wait, I actually compile after I allocate the buffers. So it probably is the allocation that takes that long. Let me just check that it's writing to the particles out buffer, and then I can move on. Man, if I ever get more serious about doing this, I need to have some kind of actual system for code reuse and like propagating constants from Rust to the shaders and stuff. Honestly, I don't remember if they have compute shaders working yet, but I do really want to check out Rust GPU, which is actually a compiler backend for Rust that produces SPIR-V for shaders. Like it's not even just macros; it actually compiles. I do really want to check that out. I'm not sure if it's like fully ready for production use yet, but it's not like I'm doing something production here anyway. Pipeline state. Oh, I'm not even binding all of my buffers for my approx. Particle buffer 1, grid approx buffer 0, 1, 2. Duh, just using the wrong shader in the first place. Okay. Okay, let me check pipeline state for that second one. Looks like I'm using the correct shader. It's binding the correct buffer, and let me take a look. And it is getting filled with stuff. I wonder if I can view it as floats instead of just bytes. It seems like it shouldn't be as sparse as this is. But maybe it makes sense. Oh, the goal of it? Okay, so it's just a gravity sim, many body gravity. It's like each of these particles has the same mass, and every particle is just exerting an inverse squared attraction on every other particle. And it's kind of just I wanted to do this as a way to get more familiar with GPU compute. I bought a fancy new GPU like 6 months ago-ish. So it was like, I want to alleviate my buyer's remorse by making it simulate a lot of particles at once. So let me think. Is it too sparse or would it make sense? So every cell is writing the average to it. Are there really a lot of cells? Let me try just shrinking the grid dimension and see if that makes it less sparse. And if so, I will feel more confident that it's doing the correct thing. It does diverge. Well, I feel like there's maybe some, like it depends on the space, right? Like I feel like you could have a space with like cyclic connectivity that could still converge, but I'll believe it that it does diverge in like a 3 torus. Maybe you can just tweak gravity, like make it a faster fall off or something to make it work. I don't know what I'm doing to make it this slow. Honestly, shader compilation is like the least fun thing to wait for. Okay, back to what I was doing. I forgot what I was doing. Pipeline state CS, grid out. Oh, that's actually showing me floats now. I guess this makes sense that very few of these cells have more than one particle in them. I mean, yeah, let me... Yeah, I guess that makes sense. I have as many particles as cells right now. I should have just done a little bit more back of the envelope math before doubting myself. So let's make it back to 1000, but let's decrease the grid size to like 8 cubed. Yeah, I think that is true. If GPUs are ever going to be like more general purpose, everything about that entire experience should be completely different, in my opinion. Okay. Yeah, let me experiment with that. Yeah, it runs instantly, so we can conclude that it is the shader compilation that is just taking insanely long for some reason. And I think it's recompiling now for RenderDoc's sake. Probably because RenderDoc is kind of replaying my commands, so it's a different binary, so they're not caching the compile. I didn't see those. Could you link them? If you could find them. Okay, grid out. There are now 8 cubed 512, which is like is on the order of about 4 particles per cell now. No, there should be more than that. Anyway, not sure what's happening to these. Extremely low numbers. Like, is this garbage memory? I am writing zeros. Or is this just... Yeah, I could never guess what that is. But yeah, that's cool. You can see it's all really bunched up in the... Oh, and another thing that I'm making a mistake here is cell 000 right now is right near the origin, and so it has 338 particles because they're all bunched near the origin at the start. And that makes me realize I didn't properly center my grid, so it's just, so I should just offset my grid by half of grid dim. Um, so let me open this up. He's the one who had the Compute Shader Ray Tracer blog posts as well, I think. Those were good. I'll read this later, but yeah. Shader compilation taking forever is a nightmare. What did I just do? Okay, so that should center my grid properly. Invalid character V and Swizzle. Oh, I just... Cool. And then I think as you go halfway down... it's not letting me see past a certain length. Okay, I have to go take care of something. I'll be back in like 5 minutes. Alright, I'm back. I hope I didn't lose subscriber while I was gone. Okay. I wish there were a way to view more than 512. Maybe I can, yeah, I can export to CSV. This is a little overkill, but I just want to see if it's correct. Okay, it's only exporting the 512, but so that's kind of useless. I have to assume that it's correct. Let me try making grid dim down to like 10, and then they'll have to be in some of the cells. Thought I already compiled you. Wait, there should only be 512. So yeah, they were all 0. I was just not thinking correctly. And somehow that offset is making them not get. I think it's just moving it outside of all the particles. Let me think. So let me calculate this as a different way. Let's just do. Oh yeah, I should only be subtracting it on the first one. But let me just subtract half the grid size because that's easier. Let me just see if invocation ID is an int. It's unsized. So yeah, I need to take an int of it, and then yeah, this should work. Hopefully we see some actual data. View contents. Still zeros. I don't know why that's happening. Let me check. Yeah, my particle positions are centered at 0. So that should be working. Frustrating. Let me change back to 1,000. Somehow I got it in a messed up state when I was trying to. Okay, so that at least made it back to working. Let me just hard code it. Didn't capture it. Pipeline state, compute shader, buffer contents. Okay, there's some data in it, and that makes sense. It's near the center, which seems to make sense. I'll just assume it's correct and then move on. So like I've implemented the binning step and the approximation step, so I should have my center of mass and total mass per cell. So now what I need to do is make the update step, instead of taking into account just all of the existing particles, it needs to use the grid buffer. And for cells that it's not inside, it just uses the. It's also going to need the grid approx buffer. So let me just get this binding stuff correct, see if it still runs, and then. Okay, so I'm binding particles, grid, particles. So this one should be index 3, and then in between here I need to have grid buffer and grid approx buffer, and they will be on. Man, I really need to just build more of an abstraction over this so I'm not fiddling with all these details every time I change the pipeline at all. Honestly, maybe I should just do this with WGPU for like when I'm playing with stuff like this. Probably would be a lot nicer to use. So it's particle buffer 1, particle buffer 2, grid buffer, grid approx buffer. I think I do need some memory barriers between these as well. So like let me just check if that's actually true. Yeah, I do need a barrier to make sure that after binning, the bin stuff is visible to the approximation. After the approximation, it's visible to the update. And then after the update, it's visible to the draw. That makes sense. So the update takes these 0, 1, 2, 3, 0, 1, 2, 3, these 4 buffers. Let me see if it still works. So I didn't break anything. So let me just, for now, make every particle only loop over the particles in its current cell, which will be incorrect, but let's see if it works. So update. So I need to find my cell index from my particle position. So what I'm going to do is, for each particle, which is one thread of this shader, I get my position, I get my previous position, I get my current cell by taking my current position, and let me copy in my grid size info. These should be uniforms, but okay, so I take cell index, no, I take my position, I take my position minus the origin of the grid, which is negative 0.5 of the grid dimensions. And then I divide this by cell size. So now if I cast this to a UVec3, this should give me the XYZ indices of my cell. So, and now I can get my cell index by doing this, except it's with a cell. So here's my cell index. And now I can get my cell by doing so here's my cell index. And then list offset is cell index times num particles. Oh, hello. Hey, Rory. I'm glad Twitch finally let you in. Okay, so I have my list offset. and my cell index, and it's let me comment this out and replace it. Hey Elliot, how have you been? Okay, so I'm looping over the particles inside my own cell. And if I'm at the end of the list, I break. Otherwise, I take the index. Okay, so this actually should already be updating me just based on my current cell. So let's see if that blows up or works properly. I've been doing well. Trying to start. Whoa, that was not what I expected to happen. I'm trying to start streaming again. Nice way to be sort of less lonely. But yeah. Okay, I do not know what's happening. I think I'm getting one frame, and then it just blows up. Okay, so... Oh, yeah, okay. It's using the wrong index. Hopefully this does something reasonable. Yeah, okay, so this is what happens when you only take into account the current cell, which basically just like things kind of settle into place, it looks like. Which kind of makes sense. So now I just need the final piece, which is looping over all of the cells globally. So I'll do that with so loop over 0 to grid size cubed. If it's not the current cell, then I look up the approximation where the XYZ is the position and the W is the total mass. So then I want to do and it linearly scales with mass, so I just want to do mass times direction over. That should be correct. And if this works, we have Barnes Hut. Right only. I made a typo there, so let me make sure I'm not. this should be read only. That makes sense. Checking all the cells is it sounds expensive, but it is much less expensive than the current state of things, which is checking all of the particles. Like, so you have to understand the current state. Okay, this is definitely wrong, but it looks cool. The current state of things is that I start a GPU thread for every single one of my particles, and then each thread does a for loop over every single other particle. So it's got n squared complexity. So it's very expensive, and like I can handle 4,000 particles in like 4 or 5 milliseconds, and then I double that number of particles, and the time like quadruples to 16 milliseconds. And if I continue doing that, it follows an n squared curve. Whereas what I'm doing here, the number of cells is much less than the number of particles. Honestly, I could decrease it to like a grid size of 4, and it would probably work. It'd probably get even, I mean, it would get even more of a speed up. It'd probably not be too coarse. But right now my logic is wrong in some way because it doesn't even look qualitatively like it's supposed to. I think probably what's happening is everything is just getting moved out of the grid, maybe? I don't know. It's hard to say. Everything just kind of stops moving. I mean, let me look at my times though. It's not a humongous speed up, but it is a speed up. Yeah, I could do that. All I'm doing for each cell though is looking up a single XYZ vector and a mass value. So like a single cell is very cheap. Like a cell is about as expensive as a particle. So I'm not actually super worried about the cost of that part. Like I don't suspect that it's a big part of the overall cost of the algorithm. If I set there to be one cell in the grid, it should go back to normal, right? Okay, I'm doing something wrong. Looks very cool. I think what's happening... Yeah, you can see this little cube where the only particles that are still getting simulated are inside the cube. So what's happening is the grid is much too small in its total dimensions. So let me just like make it 10,000 and see if it still works. Something is very wrong. It looks beautiful, but it's not at all how it's supposed to look. I mean, that's really pretty though. Definitely going in the bug reel. Let me like stash this just that I have I can go back to it and take some pics for the bug reel because I love how this looks. But yeah, I think what's happening is stuff is like stopping getting simulated because it's escaping the grid. But I thought I calculated that. Wait, you know what? Yeah, the initial thing is actually much smaller than I was thinking, so let me increase this even more and see what we get. Yeah, it's hard to get the motion blur to be exactly brightness preserving. I had to do a lot of tweaking, and initially it was actually making things dimmer. So like, that was hard to get right, and I haven't exactly figured it out. Like, you would think it's just take the area it subtends on screen and divide the luminance by that. Like, that should be the right solution, but it basically either looked like it was dimming or brightening. And I couldn't get it to like exactly look the same. And frankly, there probably isn't an exactly right one. I feel like probably that's just how motion blur will end up looking. But oh, I have different grid sizes on here. That's what I get for not having a proper uniform or constant system. Man, I love how it just freezes though. It's really pretty. Let me look in RenderDoc to see how far out these things are actually going. Oops. And also this is making me realize that having a fixed size grid really is kind of a problem. Like it'd probably be pretty cheap every frame to like write out a value in the update step for like, I think I can even do like an atomic min-max thing for like calculating the total extent of the particles. So that'd be a nice thing to do. I'm not gonna try to do that today though. Okay, so pipeline state, compute shader, particles in. Let me look at the contents. Can I please look at this as floats instead of whatever this is? Float. Vec4. Vec3 is what it should be. How do I have this laid out again? Yeah, I think it's Vec4s, yeah. Okay, there we go. Now I can actually look at the data. And yeah, none of these positions are really bigger than 1,000, actually. Some of them are, but none of them are even bigger than 2,000. So I should actually make this back down to like 2,000. Let me just give it a try. Let me reread this code again. So what I'm doing is I have an acceleration. When I write out my W, it's the number of particles. Okay, finally it looks like it did before. So this is there's no speed up happening here because this is using one single grid cell. So let me try increasing grid size to 4 and see if it looks correct. I have the scale right for the total grid size. Okay, so there are two possibilities, and one possibility is that I'm just doing it right, and it's just not that good of an approximation somehow, or I have the approximate updating part. It's using incorrect logic somehow. It's really hard for me to think of a way for me to tell if that's what's happening or not. I mean, people use Barnes-Hut in astronomy type of stuff. If I feel like it's got to be better than this. Maybe I'm building the approximations wrong. It's really hard to tell. Well, yeah, that might actually be true. It's approximating an awful lot of the particles at once with a single point mass. So yeah, I should probably try increasing it. Let's do 16 again, see what happens. I feel like it's getting longer. Really hard to tell what is the actual issue. Like in theory, as you go from one grid cell, you're not doing any approximation at all, and as you go to infinite grid cells, or one grid cell per particle, you're also not doing any approximation at all. So like, in theory, on either end, it should be 100% accurate. Let me increase the total grid size again. Draw the grid. Yeah, that would be difficult, but probably the best way to debug this. Crazy, some really anisotropic shit going on with the grid. Yeah, honestly, I need to do some better debug stuff. Well, I have some pretty bug results. Most of the scaffolding is in place for Barnside. It's just not giving me quite correct results. So I think maybe I'm gonna end the stream for this week and then probably come back to it and do some more thorough debugging next week. Figure out exactly why it's going wrong. Yeah, that's actually what I did originally too. Let me try going back to that. Let me disable between cell interactions. And hopefully I can see the grid. I feel like something worse is happening. Yeah, like these should at least be simulating within the grid, so this part may in fact be wrong. Okay, you know what? Yeah, I was just depending on I was accessing the wrong value, I think. I was accessing the current position instead of the previous position. This seems better, at least. Finding a flow by an int. Okay, I mean, may as well try. I mean, if that's it, I'm kind of mad, but... Okay, well, I think this looks a lot more correct than before. I still kind of feel like stuff should be moving within each cell. Sintel, did you experience this where they kind of like, they diffuse out within a cell and then kind of stop doing anything, or do you think it's still incorrect? Yeah, interaction is only enabled for within a single cell. Yeah. Like, was yours totally different from this, or does this kind of match yours? I feel like I can see the granularity of the cells from this. Okay, let me do that then. Initial velocity. These are the velocities. I don't know why it explodes at the start. I think these are probably escaping the grid then. Hey, Euphoclinian. Yeah, I do not know what's wrong. Okay, let me stare at my update code again. So, taking the previous position of whatever other particle, getting the direction towards it. So if I were starting all the velocities at 0. Wait, you know what? I forgot that I am using Verlet, and so I'm not storing velocities. I'm storing previous position. So I should just instead be setting previous position to initial position, and that will make it have 0 velocity. I was giving them very high initial velocity. There we go. Okay, now let me make there be like more cells. To see if I can get them clumping tighter per cell. I swear, every character I add to my shader, the compile time increases as the square of it. I honestly have no clue why it would be taking this long. I'm gonna kill it. What is happening? You know what? It's probably the memory allocation time for that big of a grid. So what instead I should do is make the grid size smaller instead of the number of cells. I don't think it's the loop, no. Yeah, there are... Well, yeah, actually maybe you're right. That might be what it is. But it was working with 16, so this should be fine. Okay. I think you can see that these are just entirely outside the grid. Or something. This is so weird. But yeah, you can tell it's not the loop over the full grid because that's happening every frame. So anyway, you know what? I'm gonna kill this and replace it with just a null again. See if that works. Because it's working for my other buffer. Hopefully that speeds up. Yeah, it was just the upload time for that massive buffer. Okay, so why would it be doing this like hamburger buns thing? Are they just outside? Yeah, I think they're outside the 1000 dimension buffer, and let me test that. I mean grid. Let me test that by doubling it. I think that's correct. There totally is. There are different ways. One of them is make it a uniform and then pass it in. One of them is there are ways to do like pound defines like in C. Or if I had some kind of Rust shader compilation system, I could just kind of like define the constants in Rust and then feed them in. There are lots of ways. The explanation for why I don't have them is I'm lazy and I'm trying to get this to work rather than make it have a good architecture. So it feels like it really looks like there are only 4 cells on the screen right now. Like these are cells, but that doesn't make sense. Anyway, I feel like I've got to do an adaptive approach that at least sizes the grid to the previous frame's maximum. Yeah, I mean, the renderer still looks pretty. Let me turn this back on and see what happens. First order, you mean just velocity instead of acceleration? Yeah, I can try that. I'm kind of running out of steam for today, though. I think I'm gonna call it good because I got the whole thing set up and like, I mean, it looks kind of cool. Like it's obviously broken, but let me turn back on depth of field and just see how it looks. Okay. Okay, this will be the final state that we get to for this week before I call it good and try again next week. Wait, I hate that. Let me change back to the other. This is the last one. I'm leaving it at. Centering of the grid? I don't think so because I'm when I'm binning things, I'm properly like subtracting it, and then when I'm finding which cell I'm in, I'm properly adding it again. So like I don't think so. But you could be right. Yeah, I'm pretty sure I'm handling that part correctly. Alright, yeah, there are too many things it could be. I'm gonna have to do some more thorough debugging next week. But I'm gonna call it good. X, Z, Y order? Where? X, Y, Z. X, Y, Z. X, Y, Z. Line 33. That's also X, Y, Z. Yeah, I don't see where that would be. Yeah, no, the stream quality. I do have a pretty small font anyway. I mean, it'd be nice if it was something dumb like that. Anyway, yeah. Okay, I'm gonna call it good though. I saved that cool looking bug so I can take some videos of it. Anyway, wouldn't be a stream without Hubble, so I'll be right back. Alright, I had to coax him awake with treats, but here he is. Let me make sure he's on camera. This is Hubble. He's got a sweater on. Hubble doesn't know what a barns or a hut is. Okay. I'll let you go back to sleep, bud. Alright, well, thank you everyone so much for tuning in. Should be doing this again next week, hopefully getting it to actually work. Anyway, signing out.